National Electrical Code Article 300.22 states that electrical installations shall not be used behind walls or other concealed locations where the conductors are subject to physical damage. Low voltage wires from a security system, such as alarm wires, can be considered as concealed conductors subject to damage if run through line voltage holes. NFPA 17 National Electrical Code 2020 Article 800.177 dictates that raceways shall not be used as a means of support for other cables, raceways, or equipment. This means that alarm wires should not be supported by the line voltage wires or holes. Line voltage and low voltage lines can create harmonic interference when run together. Harmonics are frequencies higher than the fundamental frequency, 60 Hz in North America. These harmonics can cause electromagnetic interference (EMI) that can disrupt the operation of sensitive electronic devices such as security alarms. Line voltage, such as 120 volts or 240 volts, can induce a voltage into low voltage wires, typically 12 volts to 24 volts, when run together. This can cause the security alarm to malfunction or give false readings. Running low voltage wires through line voltage holes can create a physical hazard. If the line voltage wires are damaged or moved, the low voltage wires could be damaged as well. When troubleshooting electrical problems, it can be difficult to identify low voltage wires if they are mixed in with line voltage wires. Using the same holes for line and low voltage wires can void warranties on both the electrical system and the security alarm system. To avoid these issues, it is recommended to separate line voltage and low voltage wires and have them run in their own dedicated raceways. If it is unavoidable to run them together, the low voltage wires should be protected by using a metal or plastic barrier between the two types of wiring. When low voltage and line voltage wiring are mixed, several critical problems can arise. It is important to understand these issues to ensure safety and compliance with electrical codes. Firstly, there are code violations to consider. Secondly, there is harmonic interference. Thirdly, there is the potential for low or line voltage interference. Fourthly, there are other concerns such as physical damage, difficulty in locating wires during troubleshooting, and the voiding of warranties. Let's delve deeper into each of these aspects. National Electrical Code Article 300.22 specifically addresses wiring in concealed spaces. This article states that electrical installations should not be placed behind walls or in other concealed locations if the conductors are susceptible to physical damage. In this context, low voltage wires from a security system are considered concealed conductors. Running them through the same holes as line voltage wires makes them vulnerable to damage. The National Fire Protection Association 70, the National Electrical Code, Article 800.177, further clarifies that raceways should not be used to support other cables, raceways, or equipment. This means that low voltage alarm wires should never be supported by line voltage wires or the holes drilled for line voltage wiring. Violating these codes can lead to fines, safety hazards, and liability issues. Harmonic interference is another significant concern. When line voltage and low voltage wires run in close proximity, they can create harmonic interference. Harmonics are frequencies that are higher than the fundamental frequency of the electrical system, which is typically 60 Hz in North America. These high frequencies can generate electromagnetic interference, or EMI, which can disrupt the proper functioning of sensitive electronic devices, including security alarms. The interference can cause false alarms, system malfunctions, and reduced reliability of the security system. In addition to harmonic interference, low or line voltage interference can occur when these types of wires are mixed. Line voltage, such as 120 volts or 240 volts, can induce a voltage into the low voltage wires, which typically operate at 12 volts to 24 volts. This induced voltage can cause the security alarm system to malfunction, providing false readings and compromising the system's effectiveness. The induced voltage can also damage the low voltage components over time. Beyond code violations and electrical interference, several other concerns arise when mixing low voltage and line voltage wires. One major concern is the increased risk of physical damage. If the line voltage wires are damaged or moved, they can also damage the nearby low voltage wires. This can result in electrical shorts, fire hazards, and system failures. Damaged wires can also pose a risk of electrical shock to anyone who comes into contact with them. Another problem is the difficulty in locating wires during troubleshooting. When low voltage wires are mixed in with line voltage wires, it can be very difficult to identify and trace the low voltage wires when diagnosing electrical problems. This can lead to increased troubleshooting time, higher labor costs, and potential misdiagnosis of the issue. The jumbled mess of wires can also make it harder to maintain the electrical system over time. Mixing low voltage and line voltage wires can also void the warranties on both the electrical system and the security alarm system. Manufacturers often specify that their products must be installed according to certain guidelines to maintain warranty coverage. Deviating from these guidelines, such as by mixing different types of wiring, can void the warranty and leave responsible parties responsible for repair or replacement costs. To avoid these issues, it is strongly recommended to keep line voltage and low voltage wires separate and run them in their own dedicated raceways. A raceway is an enclosed channel that is designed to hold electrical wires and cables. Using separate raceways for each type of wiring provides physical protection, reduces the risk of interference, and makes it easier to troubleshoot and maintain the system. If it is unavoidable to run line voltage and low voltage wires in close proximity, the low voltage wires should be protected by a metal or plastic barrier. This barrier will help to prevent the line voltage from inducing a voltage into the low voltage wires and reduce the risk of physical damage. The barrier should be securely installed and made of a material that is suitable for electrical applications. In summary, mixing low voltage and line voltage wires can lead to a variety of problems, including code violations, harmonic interference, lower line voltage interference, physical damage, difficulty in locating wires, and voided warranties. It is always best to keep these types of wiring separate and follow recommended practices for electrical installations. By doing so, responsible parties can ensure the safety, reliability, and longevity of the electrical system and security alarm system. Furthermore, proper separation of wiring systems is essential for maintaining the integrity and performance of both the electrical and security systems. When low voltage and line voltage wires are mixed, the potential for electromagnetic interference (EMI) increases significantly. EMI can disrupt the communication signals within the low voltage system, leading to false alarms, system malfunctions, and reduced overall effectiveness. Separating the wiring systems helps to minimize EMI and ensure that the low voltage system operates reliably. In addition to minimizing EMI, separating wiring systems also helps to prevent ground loops. A ground loop occurs when there are multiple paths to ground in an electrical system, creating a loop that can carry unwanted current. This current can cause noise, distortion, and other problems in low voltage circuits. By keeping the wiring systems separate, it is possible to reduce the likelihood of ground loops and maintain the integrity of the electrical signals. Proper separation of wiring systems also makes it easier to troubleshoot and maintain the systems over time. When the wires are neatly organized and separated, it is much easier to trace circuits, identify problems, and make repairs. This can save time and money in the long run and reduce the risk of electrical hazards. The use of color-coded wiring and labeling can further enhance the ease of troubleshooting and maintenance. In addition to using separate raceways, other methods can be used to protect low-voltage wires from interference and damage. One option is to use shielded cables. Shielded cables have a metallic layer that surrounds the conductors, providing a barrier against EMI and other types of interference. The shield should be properly grounded to ensure its effectiveness. Another option is to use twisted pair wiring. Twisted pair wiring involves twisting two wires together to reduce the effects of EMI. The twisting action helps to cancel out any interference that may be present, resulting in a cleaner signal. Twisted pair wiring is commonly used in data communication cables and is often recommended for low voltage applications. When running low voltage wires alongside line voltage wires, it is important to maintain a safe distance between them. The National Electrical Code (NEC) specifies minimum separation distances for different types of wiring. It is essential to consult the NEC and follow these guidelines to ensure that the installation is safe and compliant. The separation distance may vary depending on the voltage levels, the type of wiring, and the location of the installation. In addition to following the NEC guidelines, it is also important to consider the specific requirements of the equipment being installed. Some manufacturers may have their own recommendations for wiring practices. It is always best to consult the manufacturer's instructions and follow their guidelines to ensure that the equipment operates properly and safely. When running wires through walls or other structures, it is important to use proper supports and fasteners. The wires should be securely attached to the structure to prevent them from sagging or rubbing against sharp edges. This can help to prevent damage to the wires and reduce the risk of electrical hazards. Various types of supports and fasteners are available, including cable ties, staples, and clamps. It is important to choose the appropriate type of support or fastener for the specific application. In addition to using proper supports and fasteners, it is also important to protect the wires from physical damage. This can be done by using conduit tubing or other protective enclosures. Conduit and tubing provide a physical barrier that can protect the wires from impact, abrasion, and other types of damage. They can also help to prevent the spread of fire in the event of an electrical fault. When selecting conduit or tubing, it is important to choose a material that is suitable for the environment. For example, if the wires are exposed to moisture or chemicals, it is important to use a conduit or tubing that is resistant to corrosion. In addition to protecting the wires from physical damage, it is also important to protect them from environmental factors. This can include moisture, heat, cold, and ultraviolet (UV) radiation. These factors can degrade the insulation in the wires and lead to electrical faults. Various types of insulation are available that are designed to withstand different environmental conditions. It is important to choose the appropriate type of insulation for the specific application. When working with electrical wires, it is essential to follow safe work practices. This includes energizing circuits before working on them, using appropriate personal protective equipment (PPE), and following lockout-tagout procedures. Lockout-tagout procedures involve disconnecting the power supply to a circuit and placing a lock and tag on the disconnect switch to prevent accidental re-energizing. These procedures are designed to protect workers from electrical hazards and should always be followed. In addition to following safe work practices, it is also important to be aware of the potential hazards associated with electricity. This includes the risk of electric shock, arc flash, and fire. Electric shock can occur when a person comes into contact with an energized conductor. Arc flash is a sudden release of electrical energy that can cause severe burns and other injuries. Fire can occur when electrical faults ignite flammable materials. By being aware of these hazards, it is possible to take steps to prevent them. In conclusion, mixing low voltage and line voltage wires can lead to a variety of problems, including interference, damage, and safety hazards. It is always best to keep these types of wiring separate and follow recommended practices for electrical installations. By doing so, people can ensure the safety, reliability, and longevity of the electrical system and security alarm system. Remember the National Electrical Code, Article 300.22 as well as NFPA 70 National Electrical Code 2020, Article 800.177. These codes stress the importance of keeping the wires separate, using dedicated raceways and protecting them from damage. Failure to adhere to these standards is a safety risk. Keep the low-voltage alarm wires physically separate from the line-voltage wires, preferably in separate conduit or raceways. This prevents induction of voltage into the low-voltage wires from the line-voltage wires, and also prevents harmonic interference. Secure all wiring properly. Low-voltage wiring should not be supported by line-voltage wiring or conduit. All wiring should be secured with appropriate fasteners. Mixing low and line voltage in this manner can also avoid warranties and make troubleshooting difficult. Always be aware of safety considerations when dealing with electrical wiring and ensure that all work complies with relevant codes and standards. Seek advice from a qualified electrician.